implicit differentiation. Okay, I am going to start with you. You probably already know this. However, from Algebra 2 Trig and Pre-Calc Honors, the difference between, actually, let's erase this because I want you guys to come up with why you think, what the difference is between the two categories. Let's say on the left-hand side, I'm going to give you guys a series of equations. So equations that you probably learned in Algebra 1, some, let's say, in trig. Okay, so that's one category of a type of function. And then on the right-hand side, in a different color, I'm going to write out this other type of equation. And I want you guys to, in the chat, once you figured this out, tell me the difference between the types of functions that are in green versus the types of functions that are in purple. What do you guys think? What's the difference between the green versus the purple? Okay, very good. Green is solved for y, where you've had y isolated. Very nice. So the purple are what we call implicit equations, where x's and y's are all not collected, or y is not isolated. Whereas in the green column, you guys have that the independent variable x has already been isolated. So the implicit side, you have y is not isolated, or more formally speaking, y is not written in terms of the independent variable x. Okay, so I can say that after, especially by the end of this week, if I ask you guys to take an explicit derivative, that you're using things like power rule, chain rule, product quotient rule, that we can do the green side just fine. We can take the derivative of an explicit function just fine using the rules that we have. If we didn't have implicit differentiation, we would have to isolate y in our implicit equation. So take a look at my pointer and look at this equation. If I had you guys isolate y, you would say it's impossible to isolate y, to get y on one side and then to solve it so that it's in terms of only x. And so the question is there any other methodology that we can use to take the derivative of implicit equations? And so we use the chain rule to help us take the derivative of implicit equations. Okay, so when we have ugly equations with x's and y's mixed in, that's when we apply implicit differentiation without actually solving for it. Okay, so we'll start off with a familiar one with you guys. Example number 1 will be, how do I find dy dx, which is the first derivative, for this equation, x squared plus y squared equals 4. Now this one you could possibly solve for y. However, I'm going to say from here on out, if you guys have x's and y's already mixed in together on one side together, you're going to use and apply implicit differentiation. And the way that we do that is just adding in the chain rule part on each term that we're taking the derivative of that contains y. So for example, let's say we were taking the derivative term by term, and keep in mind that this is all with respect to x. If I take the derivative of x squared, I'm applying the power rule, bringing the 2 down, and I get 2x to the first power. Now, when we take the derivative of y squared with respect to x, what we're going to do is take the derivative like normal, almost like, think of this as a chain rule where the inside function is y and the outside function is the squared. The mommy function is the 2, the power rule. So what we'll do is bring the 2 down, and we get 2y. And now technically, y is your baby, so you take the derivative of y with respect to x. how do I say take the derivative of y with respect to x? That's technically dy dx. Okay, so each time you take the derivative of y from here on out, you guys will multiply by dy dx, or another way of saying dy dx is y prime. And many students like or prefer to write y prime because it's just faster than writing dy dx. And we go through this for the entire equation. We do term by term, even on the right-hand side. So what's the derivative of a constant 4? It's 0. Okay, and so from here, the question was find dy at dx or find the derivative. So what we do is now isolate y prime. So I'm also going to write here, I wanted to show you guys dy dx as an option of writing that, but I also will defer to writing y prime just because it's faster to do. So both are appropriate ways of naming that variable. So from here, if I were to isolate y prime or dy dx, I would just apply some algebra skills here. So subtract 2x, divide by 2y. Simplify this out a little bit and get y prime equals negative x over y. Now, sometimes the questions with implicit also tie in questions that relate to horizontal and vertical tangents. So I want you guys to have a visualization of this. If I were to ask you to graph x squared plus y squared equals 4, you know it's a circle centered at 2. Circle centered at 2 with a radius of, centered at the origin with a radius of 2. So it looks like that. And so y prime has always been defined as the derivative is the slope of the tangent line. So now if I were to draw the tangent lines where there's a horizontal slope, let's start with that. Let's say this is a horizontal tangent line. Sorry, it's supposed to go through the actual point, horizontal tangent line. And I will begin with, how do I find the equation of these horizontal tangent lines? Okay, if I asked you guys, what is the derivative of those lines? What would you guys say? A horizontal tangent line has a derivative or a slope that's equal to what? Good, so it's equal to 0, which means y prime is my derivative and it's my slope is equal to 0 when we have a horizontal tangent line. So we begin there, we set our equation equal to 0 and we solve for this equation. So the horizontal tangent line is going to occur when we're dealing with fractions, a fraction's equal to 0, or we isolate the top, simplify out the fraction by multiplying both sides by y, and we get that the top is equal to 0. So sometimes students will just say, oh, horizontal tangent lines occur when the top's equal to 0. And when I solve that further, it occurs at x equals 0. If I were to go back to my graph, I would say, okay, well, that makes sense. This point here and this point here is when x is equal to 0. Now, if they wanted you guys, and you want to read into the problems carefully, if they say, where does it occur? You can say it occurs at x equals 0. If it says find the coordinate points at which it occurs, let's go ahead and clarify that. So if they say find the coordinate points at which the horizontal lines occur, you would then need the y values at those points. Well, graphically, I know what that looks like. However, how do you guys find the y value? If you know it occurs at x equals 0, how would you then find the y values? You know it occurs at x equals 0. How would we find it at, how would we find the y values? Okay, so if you guys have any x values, if you guys want to find the y values, you would take the x value and plug it back into, good, so if we plug it back into the original equation where you have a relationship between x and y. So if I plug 0 in for x, I'm going to get 0 squared plus y squared equals 4. If I solve for that, I get plus or minus 2. So the coordinate points at which it occurs would be 0, comma, plus or minus 2. And then a variation on this type of question could also say, what is the horizontal tangent line? What is equation of lines? Okay, lines being horizontal tangent lines. Okay, so if we go back to the physical representation of these lines, the physical representation of these lines are that these lines are horizontal lines. So think back to algebra 1. Horizontal lines are y equals. So we would say that the two horizontal lines have equations of y equals positive 2 and y equals negative 2. So you would want to go back and make sure that you guys have it written in the correct form. So whether it's asking for where it occurs, for what are the coordinate points, and then finally, what are the actual equations of the lines. That's a huge hint for you guys for the free response. Going forward, you guys can make a note of that as well. I know that's an area that students have struggled in the past just interpreting the question. So I could again ask you where it occurs, what the coordinate points are, or what the equations of lines are. Okay, so let's put a spin on this now and say, what is the vertical, okay, vertical tangent lines now? Okay, so real quickly in the chat, you guys, when you have a vertical tangent line, which I'm going to draw here physically, kind of looks like the circle is inscribed within a box. What's the slope of a vertical tangent line? What's the slope of a vertical line? Very good, undefined. So if my slope is y prime, then I'm looking for when it's undefined. When is the slope undefined? When the top is equal to 0 or when the bottom is equal to 0 on a fraction? Excellent, so bottom equal to 0. So if I'm asking for a vertical tangent line, my first step will be set y prime to where the bottom is equal to 0. So in this case, I'm setting y is equal to 0. Okay, where it occurs, it most likely will ask you guys for the coordinate points for where it occurs. So if I were to find the coordinate points, I'm going to use the same strategy that I did for the previous problem, plug back into the original. Okay, so coordinate points, you guys are going to use the original equation to help you out with that. If you plug back into the original equation, this time you have x squared plus 0 squared equals 4. So we know from the graph, it's going to occur at plus or minus 2 comma 0. Okay, so now what is the equation for this vertical line? You guys, is equations of vertical lines y equals 2 or x equals 2? Y equals or x equals? Okay, perfect. We already have the x values. So there's two vertical tangent lines at x equals positive 2 and x equals negative 2. So that's pretty much it in terms of like, not it, but one of the types of applications where you have horizontal and vertical tangent lines. Now we're just gonna practice a little bit. I think implicit differentiation is pretty fun once you guys get the hang of it. So we're gonna just practice with some implicit equations. So example number 2. So this is just a straight, what's the derivative question. So let's say find y prime. Okay, and I'll walk you guys through this one. Okay, so for this one, you guys are taking derivative of technically 3 terms. You notice that the y's aren't isolated, so we're going to apply implicit on this. So in order to do that, this term has a y in it, and so does the other one. So I take the derivative term by term. Y cubed is the power rule, so we're going to do 3y squared. Took the derivative of a y with respect to x, so I'm going to now multiply by y prime. I'm going to have a minus sign. I'm going to bracket this because this is a little bit more complicated than the first one. X, y is actually the product of two functions, x and y. So we're going to have to take the derivative using product rule here. So let's say you take the derivative. I have the minus sign brought down here, so I don't have to worry about that. So really, I'm just finding the product rule on x, y. So if I take the derivative of x, I get 1. So that's 1 times y, and I leave y alone, minus, or sorry, plus, product rule, plus, this time I'm going to leave x, the first function, alone, and then take the derivative of y. The derivative of y using power rule is just 1. But because y is, we're taking the derivative of a y term, we're going to multiply by y prime. And then we carry forward the derivative all the way to the right-hand side. And this is where I see students mess up on the implicit, is forgetting to take the derivative of the right as well. The derivative of a constant is just 0. And that simplifies our expressions out a little bit. So you guys have done something similar after this, where when you guys think back to inverse functions, when you were solving for inverse, you had to like switch x and y and then isolate y. That's going to feel a lot like what the next step for this is. So now the question is, we're asked to find y prime, which means we have to isolate y prime. So algebraically speaking, I'm going to simplify this out a little bit by, well, first removing those times symbol, but also distributing the negative and breaking out of that bracket. So minus y, and then minus xy prime. So now we're left with 3 terms. This term here and this term here has a y prime in it. So we're going to take out that y prime eventually. But this guy, we can move over to the other side first. We can try to isolate y prime by moving all terms without y prime into, or move it to the other side. So we have 3y squared times y prime minus xy prime equals plus y to the other side. Okay, so what's the next step? How do you guys further isolate y prime? What do you think the next step is? Perfect, factor. Take out the y prime, and then we get that we can now divide both sides by 3y squared minus x. And so our derivative is y over 3y squared minus x. This is y prime for dy dx. So pause there for a minute. Is there any questions on? You guys can private chat me at this time or out loud. I don't mind if you guys go out loud and ask questions. Was there a step that you missed or that doesn't make sense to you guys? Okay, so for this next and last example, no, actually, no, there was another example after that. This is example number 3. Usually when you write d dx, the question is, what's the difference between dy dx and the expression d dx? D dx is an operation. So it's saying take the derivative of whatever the function is here. So if this is what I saw, it's saying take the derivative of x squared, and so my answer is 2x. When I see this expression, this expression represents what y prime is equal to, or what is the derivative? What's the first? It's first derivative. A notation for first derivative. So kind of like a notation for f of x. There's another question. Why did we attach the y prime to the x part of the product rule instead of y part on the product rule? Let's see. So this step right here, why did we attach y prime to the x part, to this part? Okay, so on the product rule, the first step was to take the derivative of the first function, which is x. The derivative of x is just 1. So we take the derivative of x, it's 1, and then we times it by y. On the next term for the product rule, this time you leave x by itself, and then you take the derivative of the other function, which is y. And the derivative of y is just 1. But then anytime you take the derivative of y, you're going to multiply by y prime. Yes. So when you're applying the implicit, you're taking the derivative of y like normal, but then you multiply by y prime. Exactly. And it's kind of strange at first, but as you get the hang of it, it gets a little bit easier. So what I'd like you guys to do for example 3 is write down the equation. And then what you're going to do is try to find the derivative. So the question is find dy dx. And let's say for this equation. And look up when you have to. I'm going to find the derivative on the screen. And so see how far you guys get with this. So find dy dx or y prime. when you're doing this example, I'm going to stay quiet and then you can glance up to see if you're getting the steps right. And then when you guys get the chance, I know I did that really fast, to check your work. I'd like you guys to check your work and see how you did. And then type in the chat for me privately if you like, or to everyone, if you got to the final answer okay. And as much as possible, I'd like to see everyone respond to that. Yes, no. And if it's no, if you didn't understand a step, let me know what step it is that you missed. Okay, and thank you guys for saying that you don't, and it's helpful for me to know if you guys got stuck on anything. Okay, perfect, you guys. So let's say there's a follow-up question and the question goes, at what x value does the horizontal tangent occur? And this period is going by so fast, I didn't realize it's almost time. Okay, so the horizontal tangent would occur when the top is equal to 0. So in this case, you set the top equal to 0, and it did ask for an x value. So in which case, when you guys solve for this, you get x equals +2. Okay, so before you guys leave, I had a chance to finish this problem in the last class. However, if we don't, then I'll just start the next class with it. This is example number 4. Sorry, that says number 4. And the notation, just like someone had asked me earlier, what is that? That's the second derivative. Okay, so this question is going to say, find the second derivative for the function 2x cubed minus 3y squared equals 7. And now I'd like you to, and if we need the second derivative, we for sure need the first derivative. So if you guys can find the first derivative for me, and then check your answer as you guys go. So just in the interest of time, I'll just say it out loud. Power rule 6x squared minus, sorry, that says a 3y squared. So minus 6y, but because it's the derivative with respect to x, I have to times it by y prime, equals, don't forget to take the derivative of 7, which is 0, and then keep solving for y prime. So subtract the 6x squared, divide by negative 6y. The derivative is x squared over y. Okay, so that I have every confidence that you guys can do. Now the question is, when I'm taking the second derivative, so this is the part where I'm taking the second derivative, we're asked to find that. So that means that for this one, you guys would have to, so let's say I call it y double prime instead. And what rule would you guys have to use to take the derivative of that? What rule would you guys use to take the, yes, quotient rule. So low d high, so low times the derivative of high minus high d low. Okay, now is the first time when I'm doing the derivative of the bottom that I have to take into account that the derivative of y is 1, but then I have to multiply by y prime. So it's 1 times y prime, all over what's below squared, so all over y squared. Now, if I take a look at this, I have 3 variables really, y, x, and this y prime. A lot of the times, the question is going to say write your answers in terms of x and y. So we want to view that y prime, so that's x and y. We want to view that y prime as like kind of like a third variable. That's not x and y. So what that means is that I'm going to take y prime that I solved for earlier, which is in terms of x and y, and substitute it in